Hey there everyone, ready for another video? This one is going to be a very important learning module, hypothesis testing. So make sure that you really understand this. This will follow you to the next exam. Level 2 will also ask you to perform understanding, answering questions related to hypothesis testing. Okay. Now, what you're going to be doing here is focus on this learning module. Hypothesis test is starting, is before linear regression. Okay, so but I like to put those two modules, learning modules, together: hypothesis testing and linear regression. There's a lot of concepts of hypothesis testing that will be asked for you understand, to remember, to perform on linear regression. Okay, so let's try to understand hypothesis testing, all the steps involved, the procedures, what it is, the possible errors that you can get, but just try to get a basic idea on how to perform a hypothesis test. Okay, and then we're going to see the next module after this one will be hypothesis test using parametric and non-parametric approach. Okay, so reminding you, the parametric approach use mean, average, standard deviations, correlations that they observe, or even more, a parametric test or parametric hypothesis test will use a probability distribution table. Okay, so think about normal distribution, t distribution, f distribution, okay, chi-square distribution. Then the non-parametric test will not rely on statistics, let's say, right, on average, standard deviations. No, right? It's when you have a population where you have no idea about the probability distribution that explains that population or that sample. Okay. Yes, you can make an assumption that if you take a relatively large sample from any distribution, you can get a normal distributed sample. That's the central limit theorem. Fine. But again, sometimes you're going to have to use a non-parametric approach, and the next learning module is going to stress that. Then after that, you're going to have linear regression, okay? Because linear regression has to come after hypothesis testing in that order, so it's easier for us to understand linear regression if you understand hypothesis test before. All right, that's it. So let's go to the learning outcomes for this module, and then we go to my notes regarding hypothesis test or testing. There you go. Hypothesis testing, right? So those are the learning outcomes. Explain hypothesis testing. Explain type 1 and type 2 errors and the power of a test. So let's see quickly here the definitions. What is a hypothesis test or testing, right? Or test of hypothesis? Well, I'm trying to find something here that I want to disprove, that I want to reject. Think about that, right? Something that you want to reject. So for example, we're going to talk about linear regression, right? So I'm going to use the example now. A linear regression, it's like an equation. Y equals a plus bx, b times x. That's simple linear equation. Now, what happens if b, the little variable multiplying the x, is 0? Think about that. Then it's not a very useful linear regression, right? Because the variable, the independent variable that predicts the dependent variable, has a 0 coefficient, right? That's what I want to reject. I want to reject that if I come up, if I did the research, collect the data, put it on Excel, right? Press there the data tools analytics, and I get the linear regression on that data, right? Well, that performance, right, will be then has to be tested to see if those numbers are really significant. That's the hypothesis test, right? It tests the significance of values, of expected values, significance of the variance between two variables, right? The significance of the explanation power of one variable related to another. So those are the hypothesis test. The correlations between two variables, we can do a test about that to see if the correlation is zero or not zero. We want to reject zero correlations, right? So you have to fail to reject that's not the correlation is not zero, and we have to test if the intercept, right, the coefficient, the multiply, the independent variables in a linear regression are all different than zeros. So hypothesis test comes for that reason, especially here for us in studying for the CFA exam. All right, good. What is the type 1 and type 2 errors? Something you need to know. Type 1 error is the possibility of you rejecting something that's true, right? When this happens, well, when you try to be so precise on your analysis, so including so many variables and so much information that maybe, right, you will make making the wrong decision of rejecting something that's true because you're so strict on your guidelines that you end up kind of rejecting something that's true. On the other hand, you can be a little lenient on your observations, on your data, on your analysis. And then if you're lenient, you're going to be open yourself for another type of error, which is the type 2 error, which you'll be accepting or failing to reject a hypothesis that's not correct. So you fail to reject something that's wrong. That's an error. So those two types of errors. Okay? Try to have a real life example in your mind that kind of tell you, okay, if this happens, that's a type of error 1, and then you associate that to the question in the exam if you get one question related to that. And what is the power of the test? The power of the test is really, right, to know. Power of the test is not the level of significance of the test. So a lot of people make that confusion. Power of a test, the power of a test is the explanation power, right? It's to see if one variable explains another, which not. That's the hypothesis test. Is the test that has significance. So the power of test is the significance of the results, not the significance level of confidence. It's not that 95%, the 99%, right, that the financial analyst wants with certainty. That's not the power of the test. The power of the test is the ability, the predictability that the hypothesis test will have to give you the right choice. That's the power of the test. Okay? All right. Second one, the second learning outcome is construct the hypothesis test. I'm going to show you the steps. There are 6 steps, logical steps, that if you understand, I wouldn't even say memorize, I would say understand, they'll be very helpful to kind of get this whole idea about the test, hypothesis test. Finally, compare and contrast the parametric and non-parametric tests. Okay, and describe situation where one is better than the other or more appropriate than the other. That's a beginning of the discussion of the parametrics and non-parametric tests, because the next learning module is going to focus only on them. So this learning outcome 3 here, we're going to compare and contrast quickly on this video. The next video, we're going to go in more depth describing parametric and non-parametric tests. Okay, good. I hope it is. Let's see now the key points for this module. So the process of hypothesis test, what it is in the process, very important. Test of return and risk. Test of risk and return in finance. So risk and return, okay, especially the return, is an expected value. Test of expected value. Okay, so if I expected X% return, let's see how far or how close I should get this as I expected. Okay, so we can test that. We can test the significance of the returns. They might have statistic significance, friends, but no economic significance at all. So you do a test of hypothesis where, yeah, that investment is good, right? The return is going to be positive. That's statistic significant. But if you implement that strategy or to get that investment is going to cost you so much, right? Then it's not economical feasible, right? It's like changing lei to gold, right? You can do that, right? You can put that in a machine, right? A very fast spinning machine. You make lei, forgot about, I'm sorry about the pronunciation here, to become gold, okay? But it's so expensive. And it's it's just impractical economically speaking, to make that, okay? To create gold, right? Which you could. So we don't do it. That's the idea here. You can have a statistic significant test, but not necessarily a economic significant answer, okay? So keep that in mind. All right. Tests concern the difference between means and dependent samples. Look, the key here is difference between means and dependent samples. So if I have two samples, I can see how dependent they are of each other, or if they are independent samples. Right? Those are the tests. Right? So the difference of the means will tell you that. Okay? Tests concerning equality of variances. Look at that. Right? Well, we're talking about samples, but we already spoke about samples, right? It actually shouldn't be in a letter E. Now I just noticed that. Should be tests concerning the difference between means with dependent samples. Right? So there's no letter E here. Tests concerning the equality of variances. Now let's talk about that too. Look, I'm going to talk about outcome D and outcome F here on the slide. Think with me. A test concerning means. Mean. Okay? Forget about the difference of means. Just like I want to do a hypothesis testing to find out if the expected value, if the average, if the mean of that sample is exactly, it's going to be different than this number, or if it's going to be higher or equal than this number. So let's say you want to get positive returns. So I'm going to do a hypothesis test to see if the returns are positive. What would I like to reject? I would like to reject that the returns are negative, so are lower than 0. I don't want a negative returns. I want to expect positive returns. That's my hypothesis test, friend. So I'm going to test the hypothesis that first I start with the one I want to reject. So we start with age 0. It's just a convention to use that. Age 0, semicolon, those little 2 dots, one on top of the other. And then you say X, or returns, lower or equal than 0. That's your first hypothesis. The second hypothesis we call the alternate hypothesis, which is returns are higher than 0. Great. So now you did that hypothesis, you stated the hypothesis. Great. Now, imagine that I don't want to do a test for expected value. I want to do a test for variance of 2 variables, or the variance of a sample, something related to variance. Okay, so I'm stating the hypothesis that the variance equals 0. I would like to reject, and the other hypothesis, the variance is different than 0. Okay, great. Now my point here: if you are doing a hypothesis test, parametric. Okay, this is all parametric. Forget the non-parametric for now. If you're doing a parametric test, and you are testing an expected value, you're going to have to use a specific distribution, a specific probability distribution to test the hypothesis of expected value. Which distributions is this one? You have 2. The normal distribution, which you barely use in real life, and the t-distribution. That's the one we're going to be focused more. So now you chose that the t-distribution, the tables, the studies on the t-distribution that has already been done, it's applicable to your test or hypothesis. Then you're going to use that distribution to come up with your conclusion, which I'm going to show when I go over my points. Now, imagine that you don't want to do the test of hypothesis, a parametric hypothesis testing for expected value. You want to do a parametric hypothesis testing for variance. Then you cannot use the normal distribution. You cannot use the t-distribution. Why? Well, several are statistical arguments. I'm going to give you just one here that does the job. Because the normal distribution, the t-distribution, accept negative numbers. It's the bell curve. You have to remember that the normal distribution is the bell curve, and the t-distribution is the leptokurtic normal distribution. In other words, it's a normal distribution that has a longer tails. Longer tails. There's some excess of kurtosis on the t-distribution. Right? Nevertheless, it's still used for hypothesis test of expected values. But if I'm doing a test of variance, I only accept the positive numbers, right? Variance, what is variance? Is the squared deviation. You got a deviation, and then you do the square root of that deviation. That's your variance. Well, anything squared is a positive number. So I cannot use the normal distribution or t-distribution. I have to use another distribution. Which one? I can use the chi-square distribution for variance tests. Or I can use the F distribution if it's variance of two samples or two variables, two populations. Okay? So chi-square, look at the name, right? Square. Not look, but listen, right? Chi-square. And the F distribution are used for variance, and the normal and the T distributions are used for expected value testing, hypothesis testing of expected value. Keep that in mind. It's going to be useful. Okay? All right. So look at that. Tests concerning means, anything, difference of means of two variable, means of that variable, whatever it is related to expectations. Mean. Every time you see the word mean, M-E-A-N, now it's expected value. That's it. So the difference between expected values. Okay? You're going to use the t-test or a z-test, which is the test we say for the normal distribution. You're going to use a normal distribution parameter, or you're going to use the t-distribution, probability distribution parameters. Now, if I'm doing a test concern two variants, that's like learning outcome F on the slide, then I cannot use normal or t-distribution. I have to use F or chi-square distribution. Good? All right, I'm going to tell more after that, after I cover the slides. When I go to my points, we're going to talk about more examples of that. Finally, parametric versus non-parametric. I already gave you kind of like an idea. We're not going to spend much time on this video talk about those, because the next video is only about parametric and non-parametric test. However, it started here, right? So the lessons that you have to follow when you go to the learning module regarding hypothesis testing for the material, the new material, parametric and non-parametric is there. All right. And then a non-parametric inference, right? An inference is a analysis, that's a conclusion, right? As an inference. I'm going to say something about something else. Good. And let's do the summary now. No, that's the summary, right? So all of those, yeah, non-parametric inference. Again, apologies for the typo here. This word summary shouldn't be there. Good. All right. So let's see if we can now stress some points, right? Some topics here, some points, some tips, give you a way so you can digest and understand better this hypothesis testing. All right, friends. So let's see. Well, the first, the learning outcomes here, we already did, right? The learning outcomes. So I don't need to do it. So for those that want to take a screenshot, go ahead. Okay. The key points as well. We don't need to do it again. Let's go straight to the points. All right, look at this. This point that I'm going to explain here is the hypothesis test and the process. So let's start with a hypothesis. Okay. All right. Look, hypothesis with E, right? It's a noun, and hypothesis with an I is an adjective. Okay. Just to let you know, I don't know. Some people ask me if I was a typo here, and it's not. All right, I'm going to state the hypothesis. Okay, so the hypotheses are always stated with equal on the parametric, okay? Equal or higher or lower, or higher, equal, higher or lower, equal. But those symbols. So look what I have here. I have x higher or equal than 0 is my age O. That's what I want to reject. In my age A, x lower than 0, it's what I will fail to reject if I don't reject age 0. That's it. Now, so x higher than equal to 0 could be anything you want, lower than 0 being anything you want. Okay? So I want to reject that the average height of a particular population is 6.5 feet. 6 feet, 0.5, which is very, very high, right? I want to reject that. I want to reject that that's the average. Well, so what do I do? X higher or equal than 6.5 feet for a population that I'm observing. I want to reject that that's the average. I want to reject it. That's my expected value. I don't, I cannot expect anything higher than the average to be higher than 6.5, right? But maybe, I don't know, right? Could be in a different land, right? All right. Then age A would be the opposite. It would be the height of that sample, that population, lower than 6.5. Okay. So anyway, anything that's expected, right? Anything that you like, well, I wouldn't even say the word expected here because you're talking about generically, right? So any hypothesis that you want to test, you can frame that way. Right. The second step, once you stated the hypothesis, which is the first step, let's do the second. You're going to identify we're doing a parametric hypothesis testing here. Therefore, you need to identify the distribution that you're going to use, right? And the test that you're going to use. So you're going to use a parametric test using which distribution? I can use, in this case here, if it's an expected value test, I only have two choices. The t distribution or the z, which is the normal distribution. Okay, I could use the f stats or the f test or the f distribution and the chi-square distribution. Stats stands for test. Okay, test. Chi-square test stats. Okay, what is the distribution? So I can use any one of those four distributions depending what I'm trying to do here. So if it's expected value, I'm most likely going to use the t distribution. We usually don't do normal distribution on those tests. Or if it's a variance test, I can do f or chi. Good. Now, step number 2, I decided that I'm going to use a t-test. Great. Then what? Then I need to see what is the level of significance of my test. Usually it's a 95%, could be 99. Lower than 95, don't think would be reliable. But could be 90%. There you go. Then, think with me. You have now is prerequisites here, huh? If you don't remember this or if you don't know this, you're going to have to go to the prerequisites of the level 1. You know that, right? Every time that there's a prerequisite showing up, I'll tell you. And if you remember, great. If you don't, if you never know, never learned, then you have to go and check the prerequisites. Okay? So take a look. Prerequisite here is that if you have the test, you decided that you're going to use a t distribution, okay? You're going to use a t distribution. You need to remember something called degrees of freedom, okay? So if you don't remember degrees of freedom, take a little review on that. But the degrees of freedom, which you don't need to worry about the exam, okay? Like much details. Degrees of freedom in combination with the level of significance in the respective table, in a T table, you give you a critical value for the step number 4. Now, for level 1, level 2 also, you don't need to worry about having to memorize. I mean, that can promise you that you do not need to memorize the table or the T distribution, normal distribution for the exam. That's not it's out of the scope. Second, I would say that with 99.9+% of certainty, I cannot promise 100, the critical value would be given in the question. So you don't need to look for it. Okay? So bear in mind that to find the critical value, you need confidence level determined by the researcher or by the financial analyst in this case, and the degrees of freedom. Okay, so it's a 95% confidence level, degrees of freedom of 1. What is the critical value? Okay, and then I put that on number 4. So that critical value, and think with me here. How many standard deviations do I have? When I think about the normal distribution. A little bit of prerequisite as well here. So think about the normal distribution, the distribution in bell curve. So we have right in the middle, we have the mean. We have 50% of the curve, the distribution is on one side of the curve, and the 50% of the values are on the other side. They are distributed around the mean, around the average. Great. Now you have to remember this from the prerequisites. How many standard deviations I have to the right and to the left when I use the normal distribution? We already covered that. 3. 3 standard deviations to the right, 3 standard deviations to the left. Okay, so that's why you say the kurtosis of the normal distribution equals 3. Okay, now the T distribution, which is a leptokurtic distribution, is a little bit more thinner on the top, but has longer tails. That distribution has a little bit higher kurtosis, so it'll be like 3.5, right? 3 point something. What is my point? My point is that 3 is the magical number here for you for critical values. Okay? Once you perform a test, you collect the data, you perform the test, you're gonna get a number. You're gonna get a t-test, a t-stats. And you're gonna compare that t-stats with the critical value on step number 4. And if your critical value it's higher than the critical value in step 4, we call that the pre-assigned or predetermined critical value, you're going to reject the hypothesis. In this case, the H0, x higher or equal than 0, you reject that if your t-test, which I'm going to show in a second how to do it, gives you a number that's higher than the number on the step 4. So what this has to do is kurtosis and the 3, etc. Well, if your calculation here on step number 5, collect the data and perform the calculation, your test, is a number higher than 3, you don't even need to have a critical value given on a problem, because you're going to reject any hypothesis that uses a t or normal distribution, not f or chi, that's t distribution or z distribution, normal. Any number that you calculate and is higher than 3, you reject the hypothesis, because you're not going to get critical values higher than 3, okay, with a 95% certainty under either distribution here, t or z. So that's good to remember. Okay? Remember that the magical number is number 3. And I tell you more, when you go to level 2, you're going to see other measurements, especially applied to linear regression, measurements for outliers. They're going to use this concept of the number 3. So if you remember that 3 is the number of standard deviations on a normal distribution that covers 99% of the curve, that's going to be helpful in the future. All right. So step 5, you collect your data. If you're doing return, collect the data and perform the test. How are you going to perform the test? I'm going to show you after, not yet. Okay, there's a little formula to do that. Okay, very simple. But you have to remember there's one formula if you're doing expected value, okay, which I call expected value. If you're doing test for expected value, there we go, put it more there. It's one thing, okay, expected value. Okay, now, and if you're doing test for variance, right, as I mentioned before, that's another story. Okay, so be careful. Okay, those are important. We're gonna be discussing as you go forward. Expected means mean. Okay, expected means mean. Variance means deviations. All right, then you're gonna perform your test. You have a test for the expected value. You have a test for variance that you don't need to worry about now because you're not talking about the F distribution. Okay, and you have another test that's important, okay, for correlation, okay, for correlation. So look at that. Maybe, I don't think you're going to have to remember the formula of the variance test. However, I will show it to you. The expected return test you need to remember, in my opinion. And the correlation test you need to remember, in my opinion. Remember, one more time, we're doing parametric testing, friends, right? Parametric testing. So parametric testing use distribution. We're going to again talk about test for expected return and correlation, but we're going to talk about on non-parametric point of view. Then it's different. Then the approach is different. Okay? The approach here is determine the hypothesis, which both tests will do. Parametric and non-parametric will state the hypothesis. Then after that we change, because the significance level, it does not apply for a non-parametric test. Okay, usually significance level, degrees of freedom, right? Those are related to parametric test. Then you have to find the critical value. Critical value is critical value is on both. Non-parametric, you could have a critical value, because you have to make a decision in the end. In the parametric, you have the critical value, except that the ways to get the critical value for the non-parametric versus parametric tests are different. All right. Once you have the critical value predetermined, you have to do step number 5, collect the data and perform the test. Now, collecting the data and perform the test, collecting the data is exactly the same step. Performing the test, parametric versus non-parametric, is different. Okay? So, I'm going to show it to you 2 non-parametric tests, one for expected values and one for correlation. Okay? Not now, on the next video. Okay? That's why I believe that tests, either parametric or non-parametric, for the expected value and correlation could be questions on your exam. Tests for variance, I don't think you're going to perform in the level 1. Definitely on level 2 is going to be more critical for you to know variance tests there. For level 1, I would say, remember that for a test of variance, you need the F distribution or the chi-square distribution. Okay? So those 2 here, expected hypothesis test for expected values or hypothesis testing for correlation, well then I think you should memorize the test, right? How to perform the test on step 5 here, okay? Which I'm going to show it to you, okay? Further down here on my notes. Okay? Then make a decision. Make a decision. If your test, I call this, that's me. Maybe makes sense for some of you, can use it. I call that the critical value calculated will be compared with the critical value predetermined. Okay? Pre-assigned. And if my critical value calculated it's higher than the critical value pre-assigned or predetermined, I reject any hypothesis that I stated here on step 1. That's it. So H0 will be rejected if your value it's higher than the critical. Okay, we call that a T-stat, or a test statistic. If your test statistic is higher than the critical value, reject. If it's lower, fail to reject. By the way, we don't say the word do not reject. We say fail to reject. Okay, fail to reject is less strong than do not reject. Do not reject is too strong. Fail to reject is a little bit in the air. Okay, so remember, fail to reject. All right, I think that's good for now. Right here, it's just like a little bit more extra information for hypothesis test. I can have a hypothesis test that has what we call a two-tail test or a one-tail test. And it's very simple to get this. It's very easy. I don't know why not a lot, but some people that I talk to, I really get confused on the tails, the test tails. And I say, why? It's not that complicated to get it, right? What's 2 tails, 1 tail? Well, look, think about the real numbers, right? The infinity, that goes from minus infinity to plus infinity, right? That's your numbers, right? What would be 2 tails? Right? 2 tails means that either if I go to the left or if I go to the right on the numbers, I can get an answer that satisfies me. That's a 2-tail test. So what is a two-tailed test? You can memorize that. It's when you state a hypothesis that has equal or different. If the hypothesis is age 0 equal to 0, age A different than 0, or age 0 equal to or different than 1, the other one has to be equal to 1. So again, if it's different than 1 is my hypothesis, then I want to reject it. Equal to 1 or equal to 0. I want to reject that. So age O equals to, the hypothesis x equals to 0. I want to reject that. Well, look, I can reject that if I get a 1 as an answer, a 2, a 3, a 4, a 5, or minus 1, minus 2, minus 3, minus 4 as an answer. So either side of the numbers, positives or negatives, will help me to, in this case. So that's called two-tailed test. Now, if you want to just test one side of the numbers, then you're going to do the higher equal, lower equal, higher or lower. Because when you do a higher or equal, then you limit your numbers. Okay, look, if it's higher or equal than 0, then forget about the negative numbers. Right? I just want to look on one side of the distribution, which is the numbers to the right of 0, higher than 0. That's one-tailed test. Okay, so there you go. So memorize the words equal or different for the two-tailed test and higher or lower for one test. Okay, higher or equal, not the symbol that's combined. You have remember here. I would say this would be a prerequisite as well, right? That higher or equal, okay, and lower and equal. Those are also one-tailed tests. Okay, they're one-tailed tests because they're limiting, right? The range, right? Or it's to the right or to the left, but one tail only. Okay. All right. So here then, age 0 expected return equals to 0. Age A expected return different than 0. That's a two-tailed test. Those ones here are all one-tailed tests. Expected return lower than 0. Well, that's one side. Expected return lower or equal, one side. Expected return higher or equal, it's one side. Okay, it's missing the higher here, but again, right? You got the. I hope you got the picture here. All right, let's talk about errors. Very simple here. So, what is a error 1, and what is a error number 2? Error 1, it's reject when it's true. Error 2 is fail to reject or do not reject when it's false. I'm going to give an example, real life example that applied for me. I've been a professor for 20-something years of my life. I'm still am, right? But now I'm independent. But before I was teaching at a university, right? For many years, I did a career in a university in the state of Vermont. Today it's called Vermont State University. And in there, right, I had a habit to be very lenient with my students that miss classes. So yeah, my argument was very simple. Look, if you're in a university, you're paying so much to be, to be there. If you don't want to show up for class, I mean, really, honestly, you're kind of doing me a favor, right? Because it's a last one that I need to worry about it, right? On my class. I know it doesn't sound very correct, I'm saying, but I'm just kind of like using it as a joking way to show to students how important they should be in class, because they're in the United States, which when I did my career. It's very expensive to go to university, even if it's a state university in my case. So reminding your students how much expensive it would be to be in the classroom would give them an extra incentive to be in the classroom, right? It's like, I pay for this, so I'm going to be here, right? That's the approach. Anyhow, so I was very lenient in that regard, because look, if you're paying for the service, if you're paying for the lawyer, right, and you don't show up for your meeting, the lawyer is going to charge you anyway, right? The school is going to charge you tuition if you show up for class or not. Okay, so, well, anyway, that was an effective way to bring students to my class, but that's not the point. The point is, when a student missed the class, the student would come to me and say, listen, professor, I have here a medical statement or some doctor's note, whatever. And I said, listen, look at me. Did you miss because you're sick? The person said, yes. That's enough. That's enough. I believe you. Boom. That's fine. I remove the absence. Which type of error I was committing here, or I was opening myself to commit, okay, is that I was not rejecting a fake excuse for a student to miss class. So I was committing error type 2. I was being too lenient. Oh, I knew that. It was a conscious decision of mine based on my premise that university students should be in the classroom no matter what. It's in their own interest. Right? If you're not, then you're kind of like making a mistake. All right. So on the other hand, some colleagues of mine in other departments, right, are very, 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 and very strict. Therefore, you could go there with the doctor himself, herself, themselves, and the professor probably would not give you an excuse for the absence, right? That's someone that could be committing an error type number 1, right? Someone that's too strict, so strict that might be rejecting some kind of excuse that's true. Like, that's my doctor's note. Oh, I don't believe this is a doctor note. But it is. Oh, but I don't believe it is. I'm committing an error type number 1. Right? So think about something that you related with, okay? That you can say, okay, in this scenario, and then you apply to the question in the exam if you get one. It's possible that you get questions about error type 1 and error type 2 because of that same reason I said many times, the number of different exams that have to be created since we change it to CBT format, 4 level 1s exam per year, and 5 days per week, average per window. So the number of exams is so many, so you have to create so many different questions. Probably type error 1 and type error 2 will be there. Now, second argument, type error 1, type error 2 are topics of machine learning and big data analysis. Big data analysis is a topic of level 1. Machine learning, a little bit. Level 2, very heavy. Machine learning, 1 learning module, only on machine learning. And big data, only 1 module on big data on level 2. Level 1, it's both combined in 1 module, the last one, module big data techniques, but it's kind of very superficial for level 1, okay? It might change, I don't know. But so far, it's a little bit superficial. So I wouldn't be too worried about the questions that you face on the big data techniques level 1, but it's worth you read. And when you get to that video, I'll explain my points. All right. Let's talk about the analysis, right? I've been telling you, right? Reject, don't reject, So what does really mean? Well, look at that. I want you to see this number here. I'm going to make it more visible for you. Look at that. Okay? I want you to see just the bounders here. Minus 2.086 plus 2.086. That creates the limit. So if you calculate, remember, it's the calculation, step number 5. When you collect the data and you calculate, I'm going to show the formula. By the way, the formula is right below. I'm going to show it. Then you're going to calculate a number. If that number goes outside the boundaries, you reject the hypothesis. But if your calculated number, take a look on this shape here, that's the t-distribution, okay? But if your number, it's inside this range, then you fail to reject. For example, you got the number, okay? You got the number 1.85. That's your calculation. Oh, it's not there. Showing up. Let's put it here. Let's say you calculate 1.85. That's your calculation. You collect your data, apply the formula I'm going to show next. Boom, you got 185. You're going to reject or fail to reject? Well, if you remember what I said, if your calculated number it's lower than the critical value, was the predetermined value is this one here in this case, 2.086, negative 2.086 positive, your number, it's right inside the curve. It's right inside the range, right? 185, it's somewhere, right? After the 0, somewhere here. Somewhere there. Therefore, you fail to reject. However, if your number was calculated was 2.85, then you're outside this range here, right? You're outside this area, right? You're in the red area that's highlighted in red. So, because 2.85 will be that way. Then you reject the hypothesis, right? All right. Negative number, same deal. If it was minus 285, then would be all the way here in this red area on the left side, okay? This is a two-tailed test because I have a shaded area here and a shaded area there. My number 2.85, I would reject the hypothesis. Any number less than 2.086, you will not reject. Now, go back to what I said about kurtosis. Look at that. I put here kurtosis equals 3. X is kurtosis. My mark is just to remind you that. In any event, you take a look on the line here, right? The maximum is going to go right here. It's going to be 3.3. Let's say 3. Imagine 3. 3 and 3. Yeah, maybe the t distribution is going to go a little bit further. But, 3 is the magical number. So you don't even need the critical value to be, in this case it was 2.086, then it has to be given. But if excuse me, let me rephrase what I said. The critical value doesn't have to be given if your calculation is a number higher than 3. Then don't even bother looking at the question. Say, okay, now I got a number here. I calculated my t calculation, give me 14.8. Do you think you should bother going to the question to look what is the critical value pre-assigned so you can compare with your 14 to decide if you're going to reject or not? No. 14 point whatever is a larger than 3 number, right? Much larger than 3. Reject it. Don't even go back to the thing. I could even care less where the critical value that they give me on this question. I don't need it. I know I will reject the hypothesis. My number is way above 3. All right? This could be very helpful, especially on level 2 when you're going to have to do more, in my opinion, more hypothesis testing, or the probability of doing those tests on level 2 is higher. Okay. Now, the formula that I was telling you is this one here, okay? This one here. Now, I put this one here because that's the one that was in the material. But I like to write it down with you here, the formula. See that T for the test, right? My test. So I put here the test equal. Look, I have a difference, right, on the numerator. Which difference is that? Is my mean, my average, okay, I'm going to put here expected. I'm going to put the mean minus my H0. Okay? And this will be divided, excuse me, by the error. That's how I like to memorize my formula for the test. By the way, this is the test for expected value. The test for correlation is different. I'm going to show the test for correlation next. So this formula that you see here, mean minus H0 divided by the standard error, okay? Whatever number you get here is the one you're going to compare with the critical value, okay? Pre-assigned, okay? That's it. That's the t-test. Excuse me, friends. Continuing here. Now, if your H0 is H0 semicolon, let's put it here below actually. Put here, look at that. H0, okay, semicolon, X, okay, higher than 0. Okay, my mean, my average given on that question, voila. On my I collect the data. Let's say I collect the data in the average that I got on my data collection, right? Let's say the average was 5. Good, that's my average, my 5. And what about the standard error? Not standard deviation. We're looking for the standard error, okay? Because we're doing it's standard error. Okay, we're not going to do the standard deviation. Standard error, let's say the standard error given on the problem, okay? If it's not given on the problem, unfortunately, you're going to have to compute, and you have to remember the formula of the standard error, okay? Well, let's say the standard error, it's going to be equal to 4. Look at that. So I want to do a test. Look at that, okay? H0, it's X higher than 0. I want to reject this. I collect data. I collect the data, got the mean, it was 5, the standard error is 4. Do I reject or fail to reject this hypothesis that the H0, it's X higher than 0? I don't know until I perform this calculation here. So let's do it. This calculation is going to be what? Pay attention, huh? It's mean, which is 5, minus 0. Minus 0. because H0 is the number. When I put H0 here on the formula, what I meant is the number that's on the hypothesis. For x higher than 1, you put 1. X higher than 10, you would put 10. In this case, is 0. So 5 minus 0 is 5. Divided by the standard error 4. 1.25. Do you think I reject or fail to reject that my H0 is x higher than 0? I don't know. Why I don't know? Because I need a critical value. I need a critical value predetermined. In that case, if you get a number lower than 3, then you go to the question and see what is the critical value, and then you compare. Most likely 125 is a low number. Imagine my critical value was 2.086. Forget the negative numbers, okay? The order inside the parentheses here, friends, does not matter. I could get an answer here that would be minus 1.25. Just disregard the negative and compare with the critical value. That's what I do, okay? So the negative number here means nothing. All right, so I would compare my 125 here with the 2.86, and I would fail to reject. Now, what about my standard error? My standard error was 2 instead of 4. So if my standard error was 2 instead of 4, then my number would be 2.5. My test, my T, my T stats. My test stats would be 2.5. 2.5 is higher than 2.086, then I would reject. Okay? Now, try to get some conclusions here, friend. Look what I did. I lowered the error, and I was able to reject the hypothesis. But when the standard error was larger, I was not able to reject the hypothesis. What is your conclusion here that could become easily a question on level 1? Which of the following could increase the probability of rejecting a hypothesis? Letter A, lower the error. Boom, that's the answer. A lower error. Increase the sample size. That's another answer. Okay? Because the standard error is the standard deviation divided by the square root of n. Standard deviation of population divided by the square root of n. Right? That's the error. If I increase n, which is in the denominator, I decrease the error and I increase my chances to reject the hypothesis. So the smaller the error, more chances to reject. The larger the error, lower chances to reject. All of those all this understanding about hypothesis tests is super important, okay? Because we don't know which type of questions they will create for the exam. So everything is possible. Good. So that's it. So the average minus H0 divided by standard error, okay? That's your, I'm even gonna leave there. There you go. Mean minus H0 divided by the standard error. Good? All right. Now, another one. This I'm just going to mention because this is going to be more level 2. It is material level 1. Yes, it is. But it is on the understand, describe, compare, contrast, not really on the calculation. So look at that. The F stats and the chi-square. Test for variance, behavior of two variables. There we go. That's the key words for when you have to use those distributions to do the test. So the F, I just put the formula here, but I don't think you need to worry much. It's called mean square, okay? Mean sum of squares, excuse me, divided by mean square error, okay? So I'm going to show in linear regression, not now, but when I get to linear regression, I'll show it to you, that the MSS, MSE are the average errors. The MSS is the good error, the good deviation, and the MSE is the bad deviation. So the intuition behind the F-test is if I have a lot of good deviations on the numerator and very few bad deviations on the denominator, my F is going to be big, very large, and I will reject any hypothesis that I stated in that case. Okay, just leave this for now because we're going to talk about this when we arrive in linear regression. Now the chi-square, okay, it's very similar to this one here. Okay, take a look. The chi-square is OI minus I, the EI divided by EI. Well, it's just like observed minus expected divided by expected. That's the chi-square test. Observed minus expected divided by expected. Okay, and then you get the number, and then you're gonna compare with a critical value. What about the F? You're gonna compare with a critical value. Now the critical values here not like 3 or forget about that thing about higher than 3 works for the T and the Z distribution. For the F and the chi-square distribution, don't memorize any numbers. Just take a look on the question, if it's the case, and compare with the critical value given in the problem for the F test or chi-square test. When do I use one or the other? Well, the F you use when you have two variables, the variance of two variables, behavior of two variables. But if I want to just do a single variance test, I use the chi-square. Okay? All right. Now the test for correlation, friends. And I honestly think you should memorize this formula here. Okay? This formula here, the R square root of n minus 2 divided by square root of 1 minus r squared. Let's digest this formula. Let's explain. I don't think this is difficult. Besides memorizing the formula, the steps that I'm going to describe here for you now are identical to the previous steps on calculation of the test hypothesis. The steps 1 to 6. Take a look. I have 6 steps here. All right? So let's see. Step number 1, define the hypothesis. Right there. I hope you can see it. Make it a little more visible. Right there. Look at that. Okay? Correlation equals 0 versus correlation different than 0. That's my hypothesis. Okay? There you go. I think it's whole, no? This Greek letter here, okay? Equals 0, different than 0. Doesn't matter. Okay? Now, which test am I going to use? It's a correlation test. You only have 2 options. Basically, honestly, you only have 1 option. The t-test. Okay? So we're going to use a t-test. Look at that. Step 2. I define it as a t-test. And if I define it as a t-test, I must use this formula here. Right? This one here. I'm going to put right below my image here on the video. Look at that. That formula, friends. This one here, okay, is the one you're going to use to do a test. Remember that mean minus H0 divided by the standard error that we just did here? Okay. This formula is the t-test or the t-stats for the expected value hypothesis testing. Now, this t-stats here, the test statistic, it's this formula here, right here, if you're doing correlation, test for correlation, okay? So it's important to observe that difference. Now you identify, the question is asking you for a parametric test of correlation, okay? You define H0 correlation equals 0, HA correlation different than 0. Second step, you found the test statistic with this formula. You're going to put the formula on the side. You're not going to do anything with this formula until you collect the data on step 5. On step 3, I'll define the level of significance. Now, in the degrees of freedom. Now, look what I have on step 4. I have degrees of freedom, okay? I have confidence level. I put everything together, and then I found that my critical value is 2.776. Take a look, right there. Plus or minus 2.76. That's the predetermined critical value that's gonna be used for comparison, okay? Now, on step 5, you're gonna conduct the test. Now, how is this test? And more likely, how is it going to be the exam question that could require you to use this formula? You're going to read the question and the correlation will be given. So it's going to be like 0.000000007. It's very close to 0, right? 0.00007. It's not 0, but it's so close to 0 that you want to make sure that's not 0. It's a tiny correlation, but it's not 0. Let's test it. Well, there you go. So you will be given the correlation. That's the R on the formula here. Okay? And the N is going to be given. And that's all you need. You need the correlation, that you want to test. Okay, remember, you want to test if the correlation is different than 0. Then you got a correlation, but again, in statistics, that correlation could be 0.99999, almost 1, almost perfect correlation, and you're still gonna have to test. Okay, just imagine that. Right? So to not, yeah, but it's so different than 0. Yes, but if it's a question in the exam, you need to know what to do, right? So imagine that you're gonna have to test any correlation that you found there, even if they are very close to 1. Okay, all right, you're gonna test, obviously, to reject that 0. That's what you want to reject. And you're going to say to me, yeah, but I got that correlation 0.9999. I can safely reject that 0. Yes, but if you want to get a PhD thesis, right? If you want to get a doctor's degree, you're going to have to prove it, friend, right? You're not going to say like to those that are evaluating, you say, yeah, by the way, we did not perform a hypothesis test because the correlation we found here is so close to 1 that was not necessary. Wrong. You're going to still have to do the hypothesis testing. All right, good. Now, let's take. In this example, the correlation was 0.8945. In N was 6. Okay, so look at that. 0.8945 is the R. Square root of N minus 2, 4, divided by 1 minus the correlation square. Okay, and I got a number 4.0 or 4. Great. Perfect. Is this number higher than the critical value predetermined? Yes, it is. Should I reject or fail to reject? Reject. Reject what? That the correlation equals to 0. Therefore, 0.8945 now is proved, in quotations, that's different than 0. We just did a hypothesis test for that. And that's it. Okay? Now, if you take a look, the exactly same 6 steps that I used for the testing of an expected value, expected return higher than 3%, I did for the expected, for the correlation, the expectations of correlation. So look at the word I'm using here, expectation. I expect the correlation not to be 0. I expect the returns to be higher than this. I expect. That's mean t-test, t-distribution. Could be normal distribution, could be. But read the question. In real life, most likely not. But in the exam, they could create a question when you're going to have to use the normal distribution. And then you're going to have the prerequisites. When to use the normal distribution, when to use the t-distribution. So very quickly, the t-distribution you use when you have a small sample, when the variance is, the variance of the population is unknown, right? Or you have some kind of, imperfections, then you want to give yourself a little bit room for more error, then you use the t-distribution. The normal distribution, you have to have the entire population of your disposal, or you're going to have a large sample at your disposal. The sample has to be normal distributed, right? So let's say the question gives you that. The sample is normal distributed. Perform the hypothesis test in this case. Well, in that case, you're going to need the normal distribution, okay? But I don't think this should be a concern in the exam, okay? The steps are the same. Define the hypothesis, right? Then define the test, define the significance, find the critical value. Boom. Compute your t-stats, compare with the critical value, make a decision. That's it for every hypothesis test. Okay? Let me prove it, or not prove it, but let's emphasize that. Okay? This test concerning equality of two variants that I said to you, don't worry about this question on the exam, but I'm putting it here for as an example purpose. This is going to be useful for level 2. No, that's almost, I can promise you. Level 1, I don't think it's going to be that critical. Okay, what I'm going to show here now. But knowing that the F-test exists, knowing that the chi-square test exists, knowing why they are used for, yes, that's important. So take a look on this test hypothesis here. So B1 equals 0, B1 different than 0. Okay, so the H0, B1, what is this B1, B, is variance, no? Because if I'm using the F-test, I'm using variance. Look at that, using a 6-step process for testing a hypothesis, the significance of the variance of two variables. Look, most of the time, you're gonna do this test, most of the time, okay? You're gonna be doing this test here, so, for X and Y. What do you mean X and Y? X and Y. Independent versus dependent variables. What is this? Well, look, independent versus dependent, the X and Y. If I have a regression, which is coming, that's why I'm opening the door now, a regression is stated basically is like this: A plus BX, for example. That's a regression. It's a line, right? It's an equation that explains something. The Y is the dependent variable. The X is the independent variable. I keep changing X and see what happened to Y, right? Good. Now think with me. X might have some variance on the input, and the Y will have some variances. Now, I want to compare that pay attention, that the variance of Y, it's actually related to the variance of X. So I want to make sure that the variance that happens on my prediction, my crystal ball is predicting something, and then it's predicting something else. Every time I change X, Y changes. I want to make sure that that change is explained by the changing X, right? The changing dependent variable. So if every time independent variable here, let's say, is advertising budget, and the dependent variable is sales, increasing sales. So if every time I increase the advertising budget, my sales change, varies, then, and I can prove that the variation on the sales, it's being done by the variation on the advertising budget, boom, I explain, I prove that advertising has an impact on the sales. That's why you do the F-test. You do an F-test to make sure that you can further say, listen, I'm using inflation to predict the interest rates, or I'm using the interest rate to predict the macroeconomic growth on the GDP, right? And if I perform an F-test on the variance of those two, and I can get a significant result, then X explains Y. Okay, then the dependent variable explains the independent variable. We don't know the intensity of the explanation on the F-test. That's one of the limitations. The F-test does not tell the intensity of how one explains the other. But the F-test will tell you that one explains with the other with reasonable assurance. Okay? All right. So that's an example on when you're going to use the F-test. But again, this is going to be something that you're going to need more for level 2. The calculation, understanding the concept, I think it's very, very helpful to learn now. Okay, but I don't think it's going to be in the exam. Yeah, I kind of agree with you. It might not. The F-test on the chi-square, maybe not. But again, it's going to be useful for you. Let me give you an example here of someone that passed level 1 without studying derivatives and alternative investments, because it's low weight. Did not study derivatives, did not study alternative investment, could care less about those topics, didn't touch. And yeah, passed the level 1, first attempt, passed the level 2, first attempt. But you know what happened? Level 3, he got stuck. Got stuck on level 3 3 times because it was missing the understanding of derivatives and alternative investments for the level 3. Point is, everything is important for the next exam, or if it is important, I'll tell you, and you should pay attention because of that, because you're going to make your life easier. That's strategic, okay? It's not a strategy like save time now to pass the exam, because you could pass level 1 with getting 0 points on derivatives and alternative investments, of course, right? You just need 70-something% to pass the exam, 180 questions, times 70-something%. You can miss like 40 questions or more, like on that ballpark. So look, if I zero derivatives and zero alternative investment, I could still pass the exam with flying colors. But it's a mistake. It's a mistake not paying attention in every single one of those modules. They are building blocks. Just remember that. All right, let's finish this example here. So without going in much details. So the formula is MSR or MSS divided by MSE, okay? The mean square regression, or the mean sum of squares, as I mentioned before, divided by the MSE. So that's the test. The only thing you need to remember is this. Look, I did a test here using that formula, and I got 30 point something. 30 point something, it's way higher than 3.9. Look at that. 3.9 is my critical value, predetermined. My calculation is 30. I'll reject the hypothesis. That's the you reject the null hypothesis that there's no explanation, that the explanation equals 0. No, actually the explanation here is different than 0, means that some kind of the variances of those variables indicate that those variables, one explain the other. Okay, that's the F-test. And the chi-square, well, the chi-square, just remember the chi-square is used for variance of one variable. Okay, test of variances of one variable to see the significance of the variance. But that's for another story, right? So two variances, use the F. One variance test, use the chi-square. And that's good enough here for me, in my opinion, for you to know. All right, very quickly, I'm going to go on parametric and non-parametric tests, because the next module is exactly about this. Okay, so we're going to talk about, again, in more details, parametric, non-parametric on the next one. So for now, I'm just going to go and give you some overall understanding of that. So I create this little table for you. Okay, the type of test being parametric or non-parametric. I explain and I give an example, kind of like just to emphasize here the difference of each one. Look at that. Parametric makes assumption about the data distribution. Which assumptions are those? The tables, the normal distribution, the t distribution, the f distribution, all those distributions, they'll have assumptions. The mean, the median, the standard deviation. So that's a parametric test. T-test used to compare means between two groups, assuming normality and equal variances. Okay, could be when I say normality, again, could be the t distribution or the normal distribution. Normality means, right, that the shape of the distribution that I'm analyzing has that bell curve shape. Could be a little bit leptokurtic, the t distribution, or could be normal. Either way, it would be used a parametric test in that case. A non-parametric does not assume the distribution. So you can have a completely a population distribution, sample distribution that you could care less how is the distribution of that population or that sample. Could be skewed, could have tons of kurtosis, doesn't matter. Doesn't matter because you're going to use a non-parametric test. So that doesn't matter. So in that regard, it's useful to use a non-parametric test when you have a population or sample that you have no means to find which distribution it follows. Okay? Again, imagine how those questions could show up on your exam as true and false, most likely, least likely. Which of the following is a characteristic of? Which of the following is not, or most likely is, least likely is, and etc. Okay, that's how you want to study for this exam. Okay, trying to predict questions, write it down. Well, imagine, because we never know. This could be there. Okay, I don't know if I'm supposed to say that or not, but I think the way you say it doesn't sound that I'm violating my code of ethics here. So I remember when I did level 3 that I did that approach. And I was reading the official material, and I was imagining, okay, this could be a question. This looks like a question. This looks like a true or false question. This looks like a most likely, least likely question. This one is a definition question. This one here is, and I just kept doing that way, right? And guess what? I actually was able to predict more or less questions that I saw in my exam by doing that approach. Okay, so again, I think it's definitely worth a try. Yeah, it's time consuming. It is time consuming, right? Because I'm going to have to create those questions. I'll read with more care for the lessons. Okay, separate. This could be a question. Maybe highlight it. Do any kind of ways that you find strategic or correct. But again, try to imagine the questions. Try to create questions. So go to the ecosystem. I did a question. Guess what? That question that you saw in the ecosystem will not be in the exam. Imagine that question will not be in the exam, but a very similar question will. or could be. So change the alternatives and become another question. Change how the question is asked. Use the alternative to create the question. Use the elements of the question to create an alternative. And that's how you start predicting possible questions for your exam. All right? Good. That's why I put this little table here, friends, because you could have a question about the difference between parametric and non-parametric on the exam, explain when to use one on the other, right? Simple questions could be an easy question, and you don't want to miss an easy question just because you didn't prepare correctly. So again, if you read every line of that official material, I think your chance of passing the exam, read and understand, obviously, are going to be super high, right? All right. So a little bit more, and then we're done here with this learning module about hypothesis test. I'm going to do a wrap up, and then we're done. All right. Non-parametric inference, because that was one of the learning outcomes, remember, is a statistical approach that does not rely on assumptions about the, look the keyword here, probability distribution of the data. Okay? I'm even going to put that in red for you here. Okay? Look at that. Probability distribution of the data. It is a flexible and robust method used when the data do not meet assumptions for the parametric. I think that's very obvious, right? Well, look, if my data doesn't have an average, doesn't have a mean, doesn't have a standard deviation, I have no clue, I cannot use the t distribution, I cannot use the normal distribution, well, forget about it. Go for the non-parametric test. So in a non-parametric test or inference, the emphasis is placed on the ranking. Look at the keyword here, ranking in order. I'm going to show, not now, but in the next video, 2 examples of non-parametric tests. They are not simple, friends. Right? That's not something simple. Right? It's something that requires, again, a method, a methodology. But if you use it, it's still, it's very well accepted in the research world, do non-parametric tests. All right. So look at this. Now points, it could become a question. Look at this comment here. This allows for more general and versatile analysis that can be applied for various types of data. Boom. That could be a question about which of the following most likely is a positive aspect of a non-parametric test. Answer, allows for more general and versatile analysis that can be applied for various types of data. See, this one little line could become a question. So just keep that in mind. Non-parametric inference is often used in situations where the data have non-normal distribution, contain outliers, or have unknown parameters. There you go. That's when to use it. Okay? So try to filter as much information as you can in terms, for example, I already said that and I will tell you before, again, go to the learning outcomes. If the learning outcomes is describe, you're going to have to know how to describe. If the learning outcome is compare, you're going to have to know how to compare. Is calculate, you're going to know how to calculate. Okay? That's why the learning outcomes are very important on this process. Grasp the learning outcomes, then you know exactly what you need to know. Okay? So if there's not a question about calculate anything in the learning outcomes, you probably wouldn't get a calculate question about that in the exam. Oh, but in the mock exam, I saw so many calculate questions on that module that didn't have calculate on the learning outcomes. Then I'll give you the following answer. Ecosystem mock exams is to prepare you. It's for you to get it. You will get some concept of a point here of a topic by doing a problem. By doing a numerical problem, you understand the concept, right? The example is this. Let's go back there. Look at that. I think now, I hope at least, you understand more a parametric test of correlation, hypothesis test of correlation, because you saw the steps. You saw a numerical problem. Does not mean a numerical problem will be in the exam, but something related that you could remember from those steps could be in the exam. All right? Okay, friends, let's see if I covered everything. No, just like a habit, I'd like to do that. All right. Explain hypothesis testing. Done. Type 1, type 2 errors explained. Yes. Power of test. Yes, the power of test is how well you can predict, you can reject the hypothesis and things like that. That's the power of the test. Construct the test, which are the steps, and compare parametric and non-parametric. Describe when one is more appropriate than the other. There you go. We cover all the learning outcomes here. Key points, right? The process of the testing, hypothesis testing, test of risk and return in finance. I gave you more example on the test of return, test of the expected return. When you talk about risk, we're talking about variances, okay? So the test of risk could be applicable to the F or chi-square, more like a chi-square test. Test concern anything that says means, it's a expected test of expectations. A test of expectations is done using the T or the Z normal test, normal distribution. Test concern equality of variances. We did the F test because there's two variants. Equality, or if testing a variance in general, is the chi-square. Parametric versus non-parametric. We did the use of non-parametric and the inference of the non-parametric test. All the key points addressed. So I'm satisfied here, friends, that we're able to cover all the important points. Of course, this is not going to be enough, right? You're going to need to practice. But I think this is a good start. So if you watch this video, I think now you have more understanding of hypothesis testing, and you'll be able to perform well the questions on your exam. Right? Again, I want to finish the video saying, I do not believe that you're going to have complicated, heavy question on hypothesis testing on your exam. I probably went further than what you're going to see in the exam, but I'm telling you, it's going to be extremely helpful for level 2 exam. You know, you're going to see it when you get there. Okay, you're going to remember me, I hope. Okay, that's it, friends. That's the end of the video. I will see you in the next one. Bye-bye.